Perfect. All right. Hello, everyone. Thank you so much. Welcome to our event, Is Solar Geoengineering a Viable Tool in the Climate Policy Arsenal? I'm Shannon Christensen. I'm the Senior Research Coordinator for the MANN Research Group, and I'll be assisting today with the Penn Center for Science, Sustainability, and the Media. We'd like to thank our co-host, Kleinman Center for Energy Policy, and Perry Worldhouse for hosting with us today. So I'm going to start by introducing our moderator and panelists. Our moderator is STACY-ANN Robinson. She is an assistant professor of environmental studies at Colby College, having held previous appointments at both Yale University and Brown University. She researches the human, social, and policy dimensions of climate change adaptation in small island developing states, with a special focus on climate justice and adaptation finance, an area in which she is a certified expert. Her work has appeared in Nature, Nature Climate Change, Wiley Interdisciplinary Reviews, Climate Policy, and other leading journals. She is also a contributing author to Chapter 15, Small Islands, of the Working Group 2's contribution to the IPCC 6th Assessment Report, which was released in February of 2022. Outside of academia, Robinson has 15 years experience in government, nonprofit, and private sectors, including time spent representing the government of Jamaica, the Second Committee, Economic and Financial of the United Nations General Assembly, and the International Seabed Authority. She is the 2022 to 2023 Lightning Scholar at Perry Worldhouse. Up next, we have our first panelist, Michael Mann, who is a Presidential Distinguished Professor in the Department of Earth and Environmental Science here at the University of Pennsylvania, with a secondary appointment in the Annenberg School for Communication, and he is also the Director of Science, Sustainability, and the Media. His research focuses on climate change and climate change communications. He was selected by Scientific American as one of the 50 leading visionaries in science and technology in 2002. He was awarded the Hans Oeschger Medal of the European Geophysical Union in 2012, and he made the Bloomberg News list of 50 most influential people in 2013. He has received the Friend of the Planet Award from the National Center for Science Education, the Stephen H. Snyder Award for Outstanding Science Communication, and the Award for Public Engagement with Science from AAAS, the Climate Communication Prize from the American Geophysical Union, and the Leo Szilard Award of the American Physical Society. He received the Tyler Prize for Environmental Achievement in 2019 and was elected the National Academy of Sciences in 2020. He is a fellow of AGU, AMS, GSA, and AAAS, as well as the Committee for Skeptical Inquiry. He is co-founder of realclimate.org, authors more than 200 peer reviews and edited publications, as well as numerous op-eds and commentaries, and also has 5 books, including Dire Predictions, The Hockey Stick and Climate Wars, The Madhouse Effect, The Tantrum That Saved the World, and The New Climate War. Up next, we have SHUCHI TALATI. She is an emerging climate technology and governance expert. She just launched a new NGO earlier this week called the Alliance for Just Deliberations on Solar Geoengineering, which focuses on building equitable decision-making processes around research and the potential deployment of solar geoengineering practices. She is also currently a co-chair of the Independent Advisory Committee to oversee ScopeX, which is an effort to provide oversight for the potential outdoor solar geoengineering experiment proposed by Harvard University. Dr. Talati is a visiting scholar at the Kleinman Center for Energy Policy here at the University of Pennsylvania, and she is also a scholar in resident at Forum for Climate Energy at American University. She most recently served as a presidential appointee in the Biden-Harris administration as Chief of Staff of the Office of Fossil Energy and Carbon Management at the U.S. Department of Energy, where she was focused on creating just and sustainable frameworks for carbon dioxide removal demonstration and deployment. She has also worked on climate governance at multiple nonprofit organizations and the U.S. Senate. Dr. Talati earned a BS in Environmental Engineering from Northwestern University, an MA in Climate and Society from Columbia University, and a PhD from Carnegie Mellon in Engineering and Public Policy. Finally, we have Michael WEISBERG, who is Bess W. Heyman President, Distinguished Professor, and Chair of Philosophy, as well as Senior Faculty Fellow and Director of Postgraduate Programs at Perry Worldhouse. He serves as Editor-in-Chief of Biology and Philosophy, Advisor to the United Nations Framework Convention on Climate Change Nairobi Work Program, Climate Advisor to the Republic of Maldives, and directs Penn's campus-wide research in the Galapagos. He is the author of Simulation and Similarity, using models to understand the world and the Galapagos, Life in Motion, as well as contributing author to the IPCC's Sixth Assessment Report. Much of Professor Weisberg's research is focused on how highly idealized models and simulations can be used to understand complex systems. He also leads efforts to better understand the interface between humans and wildlife and between humans and the climate system, as well as how scientific issues are understood by communities in the Americas and East Asia. Professor Weisberg received a BS in chemistry and a BA in philosophy from the University of California, San Diego, and continued graduate study in philosophy and evolutionary biology at Stanford University, earning a 2003 PhD in philosophy. So before I turn the floor over to our panelists today, I would like to remind everyone on Zoom today that we will be monitoring the Q&A chat for the discussion at the end. So without further ado, please join me in welcoming our panelists for today. Good afternoon, everyone. Welcome to what I'm hoping will be an exciting and intellectually stimulating conversation on solar geoengineering. And what an esteemed panel that we have today of very esteemed scientists and critical thinkers. And we're just looking forward to the insights that they will share in guiding our conversation today. So as you may know, all types of solar geoengineering, also known as solar radiation management or SRM, are united by their goal of limiting the effect of sunlight on the Earth. Some of the most recently published literature shows that using SRM has the capability to indirectly lower the amount of CO2 in the atmosphere by stemming permafrost melt, reducing energy sector emissions, and causing changes to the carbon cycle feedback. But there isn't only one way to do this, right? And this is why we're having this conversation today. And we know that there are wide variations in approaches and methods. So in some corners, we're hearing about reducing heat trapping clouds. In other corners, we're hearing about releasing aerosols into the stratosphere. And yet in other corners, we're hearing about sending a giant sunshade up into orbit. While these approaches and methods could theoretically lower global warming, they do not aim to reduce the amount of greenhouse gas emissions in the atmosphere. They would not be able to directly address some of the climate impacts that we're seeing in small island developing states, such as ocean acidification. And this to me signals that there's actually a justice dimension to this conversation. But SRM, it's not a new idea. We've been here before, and scientists and politicians have been debating it for more than 50 years. And to date, many of the studies are based on computer simulations, and very little field research has been done. So naturally, there are fears around the potential risks of SRM, including whether a geoengineered world could come with its own set of environmental and social challenges, which could in fact be comparable to climate change. So how can we be sure that this is the right approach? Is this the approach that we need? Are we sure we know what we know? Or is this all a pipe dream? So we'll spend our time today tackling about 6 questions that are prepared. These 6 questions were, for me, at the top of my mind, and I hope you're also thinking about some of them. And we'll use the remainder of the time to tackle some of the questions from our live audience and from our audience on Zoom. So without further ado, like any good academic discussion, and certainly for the purposes of our conversation today, what is SRM? What are some examples? Which technologies can be used, if any at all, in combination? SHUCHI.
Thanks so much, Stacy. And I'd love to spend more time doing introductions for ourselves, but I'll just jump into this question around what solar geoengineering is So solar geoengineering refers to large-scale interventions that reflect sunlight to cool the planet. And there are two main methods that are discussed in the literature and in the debate: stratospheric aerosol injection and marine cloud brightening. And so stratospheric aerosol injection, or SAI, simulates the global cooling effects of large volcanic eruptions by injecting sulfur or other aerosol particles into the stratosphere to reflect a very small portion of incoming solar radiation back into space. If it were ever deployed, it would have global impacts, reducing temperatures and affecting precipitation patterns around the planet. Marine cloud brightening, on the other hand, involves spraying sea salt into low-lying marine clouds to enhance their brightness and reflectivity, leading to regional scale cooling. But it could potentially be scaled up to have global impacts and could cause many other impacts at regional scales. And we don't have a good understanding of cloud physics to understand potential ricocheting impacts on top of that. Our understandings thus far in this space has been based on natural or accidental experiments like volcanoes or strip checks, as well as computer modeling. For stratospheric aerosols, the most recent example came in 1991 from Mount Pinatubo in the Philippines. And so in the aftermath of that eruption, we actually saw a global average cooling of over 0.5 degrees Celsius that was sustained for over a year. And so we know that it would result in relatively fast ascending temperature change and would also come with likely low direct costs. I want to emphasize here, however, and as Stacy mentioned, solar geoengineering would not address the root cause of climate change, as it does not address emissions, and the direct costs don't include things like monitoring or a good governance system, the cost of which could be pretty high. Solar geoengineering could help reduce some of the major climate risks like temperature rise, like the rate of sea level rise or extreme events, but there's still a lot of major physical and social risks and questions, such as the uncertainty around the impacts on regional weather patterns and precipitation. There's also considerable debate on whether or not these uncertainties could be reduced without larger scale experiments. There are a lot of other risks that are often talked about in this space. I won't spend a ton of time here, but there are things called like termination shock, which refers to what would happen if we deployed solar geoengineering and then stopped. There are things called moral hazard, which refers to resources or time on solar geoengineering being used as a way to, deter mitigation or adaptation efforts. And there are also a lot of geopolitical risks around solar geoengineering that I'm sure that we'll get into in the conversation today. But one thing I want to say is, as we think about solar geoengineering, we have to think about it in the context of the dangers of climate change and not in a vacuum. Solar geoengineering does not exist on its own, and we have to think about how those risks represent themselves as climate change evolves and impacts worsen. We have very limited research thus far to know any of the real answers to these questions, especially around the impacts solar geoengineering could have. It is around different regions, but there's starting to be a lot more momentum in this space across the academic, media, public and private spheres, and we need to start having a much broader conversation about what this means.
All right, thank you so much, Shuchi. I heard some very key words. I heard accidental, I heard risk, I heard hazards, I heard shock. So without a doubt, there's quite a bit of uncertainty and possible unintended consequences associated with these technologies. So what does SRM mean for the precautionary principle in particular? Michael.
You're setting me up for that one, aren't you, Stacey? Well, let me just start by saying it's really, really wonderful to be here, and really thank you to Center for Sustainability, Science, Sustainability in the Media, the Kleinman Center, and Perry World House to bring this event together. We've all been so gentle in this introduction and both of you guys, but I think for those that don't know this area, this is a topic that generally is not discussed dispassionately, and it's actually a real testament to the climate community at Penn that we can actually have this conversation really substantially, and I hope really make progress, at least to set a kind of research agenda for ourselves. So I just wanted to thank you, and especially to Stacy for this excellent moderation. Okay, so you asked me about uncertainty and about the precautionary principle and risk. I guess just to begin with, as you say, like we are in this sort of, we're in a bit of a bind, because part of the reason that people have been reluctant to do a lot of research about SRM is because of uncertainty. But the reason there's so much uncertainty is because there's very little research that's been done about solar geoengineering. In particular, there's been a reasonable amount of simulation work, but very, very, very little experimental work on any of the aspects on what materials might look like in the atmosphere, on what technologies might be used to deploy those materials into the atmosphere, and hence we, look to natural experiments like volcanic eruptions for them. So, one of the challenges to answering a question like our guiding question here, if it's an available tool, is no one knows the answer to this question, in part because we're sort of stuck in this. There's risk that's perceived and uncertainty, but we can't get out of that because we haven't done research. So I think one thing, and part of the importance of these discussions, is to try to find a way to use, I am supposed to be a philosophy professor, so to use the metaphor from Wittgenstein, to find the way out of the fly bottle was the metaphor he gave. The fly bottle is the fly trap. So I want to just say something about risk and something about precautionary principle. So I think one thing that's useful to put on the table is the way that the IPCC understands climate risk. Maybe it's just a useful framework for us. So the IPCC says you can't think of climate risk just as changes to the physical environment, what they call hazards, but it's a combination of those changes to the physical environment, exposure, which is basically where people are living, and then this kind of more somewhat amorphous concept of vulnerability, which has to do with the ability of ecosystems or populations to respond to climate emergencies. So if you were to think of two islands that are at the same latitude, New Zealand and Madagascar, you could, even without going into kind of a detailed analysis, you have a sense that they would just face different fates, even if the environment was changed in the same way for them. So Stacy mentioned in her introductory remarks, and I know we're going to get to this, in thinking about the risk of climate change itself or responses to climate change, like solar radiation management, the actual risk involves not just whatever physical changes we make to the environment or don't make to the environment, but also the capacity of social systems to respond to those changes. So I think it's really useful to have this IPCC framework. On the specific point of the precautionary principle, as Stacy knows, and probably why she asked me, I'm not a big believer in the precautionary principle, and that's because it's both a kind of amorphous idea that it means many things to many people, including do no harm, including don't let lack of complete, research or certainty keep you from taking an action. I think in cases like geoengineering, it doesn't tell us anything. It could be used to advocate for doing it and for not doing it. I mean, if we think that there's going to be a collapse of an ice sheet or an extreme heat wave that's going to kill millions of people, is it precautionary or not to try to use geoengineering? Who knows? So I think I think the real answer is to not appeal to things that sound good like precautionary approaches, but actually to try to do a real risk analysis. But to do real risk analysis requires having an understanding of what the risks are, which presumably requires doing research into what the consequences would be for these the deployment of these kinds of technologies, which we're not going to make any progress on if we continue to talk about things like the precautionary principle. So with that bomb, I will turn my microphone off.
All right, so what I'm hearing is a possible tension between risk management approaches and the precautionary principle. And we now know that we're approaching new frontiers, right? So do we need new principles? Do you have any different thoughts on this, Michael Mann?
Well, thanks. And let me first of all thank the moderator and my co-panelists for being involved in this conversation. Like Michael, I think one of the great things about the environment we have here at Penn is that we can have these kinds of conversations. We can have different viewpoints, and I'll get to that in a moment. But we can discuss them civilly and rationally. And I think this particular event is a testament to that. So I'm proud that our center is co-sponsoring this along with Perry Woldhouse and the Kleinman Center for Energy Policy. So let me talk a little bit, first of all, about the precautionary principle, because I am, in fact, an adherent to the precautionary principle. And to me, there's a much simpler version of that, which is perhaps familiar to people in the climate space. There is no planet B. That's sort of my version of the precautionary principle. If we screw up this planet, there's no other planet to go to. And that's not just us, but all life that we know of in the universe at this time. With geoengineering, I do think that there is the potential that it does violate the precautionary principle, because this is an intentional intervention with a system that we don't understand perfectly. And one of the examples here, in fact, Michael talks about the possibility, for example, of warming in Greenland leading to the collapse of the Greenland ice sheet, and that would be catastrophic. And that warming, as we know, is caused by an unintentional manipulation of our environment, fossil fuel burning and the elevation of carbon pollution in the atmosphere and the warming of the planet that is causing that. So that's an example of an intervention. Can we offset that with yet another intervention? Again, with a system where there's much uncertainty. And one of the things that I often like to quote when I talk about this is an old children's song we all grew up, many of us grew up learning, there was an old lady who swallowed a fly. Because then, she swallowed a frog to swallow to get the fly, and so on until she eventually swallows a horse. And of course, it's the horse that kills her. So could geoengineering be the thing that sort of pushes us past our our level of adaptive capacity, our vulnerability? Uncertainties are such, for example, that if we do this, one of the things we know from volcanic eruptions, and not every eruption is the same, the aerosol is often injected into different latitude bands, and the atmospheric response to that is highly variable. And there's a lot of noise in the climate system. But among the things we know from the response to volcanic aerosol cooling is a tendency for the drying of the continents, a slowing of the hydrological cycle, changes in atmospheric circulation patterns, and if sustained, changes in ocean circulation patterns. And we cannot rule out that if we were to engage in this particular type of intervention, we cannot rule out the possibility that while some areas will cool, other areas may warm due to changes in ocean and atmospheric circulation. That could mean that parts of Antarctica or Greenland actually warm faster because of this particular intervention. And so, again, uncertainty isn't our friend here. We're dealing with a system we don't understand perfectly. And I'll give one more example because it ties into some of my own past research. Back in the late 1980s, James Hansen made some famous predictions with rudimentary climate models at the time. And he predicted the future warming of the planet. That's proven prescient if we continued to burn fossil fuels as we have. But he also predicted the response, the cooling response to the Pinatubo eruption that was in 1991. And he actually, somebody mentioned, I forget whom, maybe it was SHUCHI, that there was a cooling of about 0.5 degree Celsius in response to the Pinatubo eruption. Hansen predicted a roughly 1 degree Celsius, almost 1 degree Celsius cooling of the planet. The radiative considerations might imply more than that 0.5 degree Celsius, but there was something else going on. There was a very large El Nino event that happened to happen around the same time. Some of our research has investigated the response of the climate system, the response in particular of the tropical ocean atmospheric dynamics that comprise the El Nino phenomenon, the response of those dynamics to a large impulsive cooling like a tropical volcanic eruption. And processes, by the way, that aren't well captured in current state-of-the-art climate models. They don't reproduce what we actually see in the observations. There's a tendency following a large volcanic eruption for an El Nino-like response of the climate system. El Ninos are warm in the tropical Pacific. It elevates global temperature. And so part of why the climate didn't cool as much as was expected was because of this El Nino that arose, which may in fact have been in part a response to the volcanic forcing itself. So this is an example, we know that El Nino can have all sorts of impacts around the world. A large El Nino event can lead to, flooding rainfall on the west coast of the US, droughts in other regions. And so this is yet another example of an area where, the models aren't yet detailed enough to faithfully capture these sorts of dynamical responses. And so we're operating with quite a bit of uncertainty. And again, coming back to the precautionary principle, where there's uncertainty when it comes to planet A, the planet we live on, precaution is, in my view, well advised. And so, as many of you probably know, I'm somewhat skeptical about the use of, for example, solar engineering as a climate mitigation approach. And there are other reasons as well that have to do with moral hazard. Does it just provide an excuse to polluters to continue with business as usual? But I respect the fact that I have colleagues here who have a different view of this, and that's why we're here, to sort of air those different views and let people come up with, come to their own opinions about this.
All right, thanks, Michael. Or Michael here has a burning intervention, but I told him just to hang on, just hold on. He can do it. And I
could
just,
stay on this question for the whole time.
right. But given your skepticism, Michael, and what I heard was, this intentional intervention, how should we be thinking about SRM in our overall climate strategy? Is it a complement, or should it be a substitute?
Yeah, so again, people in the audience who have read what I've written before about solar geoengineering know that I'm skeptical for the reasons I've already explained. But at the same time, I appreciate efforts by people like SHUCHI to argue for at least having some sort of governance structure for talking about it, because there is the potential that we could see a rogue geoengineering experiment gone awry, and there have already been multiple films and TV series episodes about that sort of scenario. And so whether you support solar geoengineering as a potential tool in our arsenal, or you don't, hopefully we can agree that it probably makes sense to be thinking about some of the larger issues of governance.
All right, thank you. Well, this provides a nice segue to SHUCHI. Could you provide some more context in terms of the governance structure that we might need, and just some further comments on where it should sit in our overall strategy?
Yeah, absolutely. I mean, I'll say that, regardless of whether solar geoengineering might work or it might not, we don't know the answer to that. But even if it could only ever be a temporary complement. And I think you'll find that there is widespread agreement around that statement across the solar geoengineering community. Robust mitigation, adaptation, carbon dioxide removal have to remain the priority, and it should remain that way. I think, when we think about solar geoengineering, the problem is that, this space has remained so taboo, is risky to even talk about for so long, that we're vastly behind in understanding the role that it could play. And something that I think is also really important here is who's been participating in that conversation. And so, often when we talk about, solar geoengineering, we focus on outcomes, we focus on what it could potentially do or not do, and whether or not we should even be talking about it. But I think the critical questions to me are really around how we make decisions and who gets to be involved. And so that's a question of procedural justice. How do we make decisions, and how do we actually fairly represent views on this topic? How do we build inclusion? And it's climate vulnerable communities and countries that are the people with the most to gain or lose from research and knowledge in this space. But right now, discussion, research, and actions around solar geoengineering have been almost entirely centered in the global north. And we're seeing a lot of actors speak on behalf of the global south in whatever way serves their narrative. And it's a huge problem. And so as we think about, how we build governance structures, the question to me is, what are the missing pieces to actually build good governance? And that's knowledge, it's capacity, it's participation, and all of that has to be, widespread. And efforts to actually build that out are not happening yet. And so that's the work that I'm focused on with my new organization.
All right, thank you. So just to focus on one of the words that you mentioned, capacity. Am I correct in thinking that the capacities lie mostly in the global north countries? And, we hear of efforts in the US, in this country, in Germany, but are global south countries being left behind from your perspective?
I think right now they are. And I think one of the big problems is this taboo that I talked about. I think there's been a very colonialistic nature to the conversation that we've been having, where it's global north actors who are either advocating for or against moving forward on this work. And so as we think about the capacity that's missing, every sector across the global south has largely not been included in this debate, whether that's scientists and academia, whether it's civil society and policymakers. That capacity just really isn't there. And this capacity has to be built. It needs to be locally owned. It needs to be locally driven. It needs to be broadly participatory across sectors. We can't, kind of build upon the colonialistic structures that we've seen in capacity building in the past, but we have to figure out ways to build this out well and build it out quickly. I think we have a really narrow window of opportunity to actually build out the foundation necessary to get to just outcomes in this space. And I think without that, I think we're going to start seeing a lot of political demand shifting around this, and we won't be prepared to handle it.
Right, thank you so much. So we could spend quite a bit of time on governance, and I want to talk a little bit about regulations and compliance, and I'm going to turn to Michael for this question. Is that I imagine that some countries might be tempted or would actually want to conduct unilateral action in this space, right? So what regulations do we need to prevent unilateral action? And what sort of enforcement mechanisms might we use to bring those countries back in line?
Get all the good ones. But I very briefly want to just to slightly respond. I just would say that, I mean, we agree, Mike, on almost everything, especially the fact that there's so much uncertainty. And in fact, I think I put the spin of, and therefore we should try to reduce the uncertainty. But where we disagree, I think, is on what precaution could mean. I mean, we all agree there's no planet B. But I think, as Suji was saying, it's like no one serious is contemplating anything in this space as some kind of solution to the climate crisis. This, at best, if it even could work, would be a temporary emergency measure. And as you say, like, we don't even know whether that would work. But I mean, I think that it's very easy and I'm not saying that this has come up today, but one often sees in the CSOs a kind of comparison of geoengineering to aggressive mitigation. And I mean, that's not like, you don't want to do which is better, geoengineering or mitigation. I mean, some people might want to have that discussion, but I don't want to have that discussion. I hope none of us want to have that discussion. It's really a question of if our efforts are failing and we are that close to the brink. And I even think it's actually interesting, like for certain kinds of, I don't understand how a decision for deployment could be made for something like an ice sheet collapse. I mean, by the time it collapses, it's too late, but it's more like the scenario that Kim Stanley Robinson imagines, like if there was an extreme heat wave that killed millions and millions of people, and you forecasted that to keep happening again and again and again, you could, this gets to the question of your question, Stacey, it does. You could imagine then a situation where a country that was very vulnerable to something like a heat wave again and again and again, begin to think seriously that this is something that needs to happen. And in fact, that is the scenario, if those of you read Ministry of the Future, that the book begins with. There's 20 million people die in a weekend. And then the Indian government says, okay, so now who's going to, like, we got to try something. And I think, so it's very easy to say, well, what kind of global regulatory structure do we need? But on scenarios, at least that I can imagine, where you could actually imagine deployment happening, I don't know what kind of global regulatory structure could stop it. It's one of the reasons why it's so important to have these discussions ahead of time, so that there's some shared understanding about these things. But I mean, let's try to think about it for a second. So Indonesia, I can't talk about the country that I represent, and I assure the audience who's listening, I am doing this in an entirely personal capacity. Minister Shauna, if you're listening, Indonesia decides to make a deployment as an attempt. Does the Security Council discuss this? If so, what are the interests? Does the General Assembly discuss this? If so, what are the interests? The UNFCCC discusses this. It's hard to adopt an agenda sometimes in the UNFCCC. So I actually don't think, I think the Security Council is probably the most likely place that some substantial discussion of this could happen, but I think it really depends a lot on what happened that triggered it, who deployed it, what, if anything, is known about the risks. So I think, I know that there are a lot of people thinking about what regulatory body should exist, but I fail in my imagination to see an international framework that could regulate it. Now, if we mean governance in the broader sense of like having developed shared understandings about this is the break the glass because, as Mike said, this could make things worse and not just better, then I think that it's really important to do this kind of discussion again and again and again all over the world with lots of people to really build up shared understandings. But if you actually literally mean, could you imagine a Security Council resolution that stops it? And if a country doesn't stop it, you know, are we going to send in the UN black helicopters? I mean, I really don't understand. Like, it's hard for the UN to even stop an invasion of a country, let alone people trying to presumably save lives in a country. So sorry for
Before you
skeptical
jump
answer.
in, Michael, I'm going to ask for reactions, but I'm asking the audience to prepare your questions. So right as we hear from Michael, and if Shuchi has some contributions to make, we're going straight into audience questions.
Yeah, thanks. Just a few quick thoughts. And, you know, Michael and I actually agree, as he said, on a whole lot here. One thing I would say is that it isn't quite true that nobody is talking about geoengineering as a substitute for mitigation. Rex Tillerson, the former CEO of ExxonMobil, once famously said, climate change is an engineering problem. So clearly there are people who do want to frame it that way. Saudi Arabia is extremely bullish on geoengineering and not so much on mitigation. In fact, they've done pretty much everything they can to gum up the works when it comes to international agreements on climate mitigation. So there are some bad actors in this space, and they have sought to weaponize geoengineering for their own agenda, even if the rest of us obviously aren't doing that. And so I just think we have to be aware that there are some bad actors that are trying to put their thumbs on the scale. Kim Stanley Robinson, great book. If you haven't read Ministry for the Future, I actually have had a couple conversations with him about the book. You can Google it. It was a lot of fun. And I can't remember what the third point was, so I'll just leave it at that.
It was radical agreement, I think, Mike.
No, I just wanted to add that I think there are really critical power dynamics that exist in the ways that we're having these debates right now. And I largely agree with my co-panelists, but I think, you know, who's even able to access these conversations, who's able to have them, is such an important question that I think the space really hasn't tried to kind of deal with yet. And solar geoengineering doesn't exist yet, right? We have this huge opportunity to build an infrastructure that looks different. And it's so unique that there are inherent challenges, as Michael pointed out, around global governance that works, but there are also things that could, you know, encourage, you know, building better global regimes around public participation or capacity building that we have been largely unsuccessful at in the past. And I think when we hear a lot of arguments around, you know, shutting down solar geoengineering conversation or research because good governance isn't possible, that's absurd to me, right? Governance is needed no matter what you decide about solar geoengineering. If we collectively decide as a society that solar geoengineering, there needs to be a moratorium on something, that requires good governance. And good governance means so many different things. And I think we often think of it as this like restrictive regulatory thing, but governance also means building knowledge, participation. It means potentially funding responsible research. It means creating regimes around how to build better research. And all of these things are conversations that we really haven't sought to have as a climate community. And that has to change. Not talking about solar geoengineering does not make it go away.
It's not like Fight Club.
Sochi, I have actually a question about what you envision. I mean, of course, I obviously really radically agree with you on the like need, you know, to actually, especially because, you know, I work with the global south and these things and to include voices. I'm just trying to understand what you envision in terms of buy-in, or, you know, like, so you said, well, you could have, I'm not, and again, I know you're not advocating this, but there could be, you could imagine a global moratorium that was endorsed, but who would endorse it? I mean, take this country, there's, you know, luckily not half, but, you know, a very large fraction of this country that doesn't endorse any climate action, or, you know, resists COVID vaccines. And that's in a country where there is actually pretty high level public discussion about this. And it's, you know, I mean, it just seems like there's going to be a huge diversity of voices. And hence, that's why I was saying, I think in the larger issue of governance of just like, we all need to participate in the discussion so that there's real understanding and kind of, you know, sharing of views. I totally get that. It's hard to me to imagine, since a small group of people can't come up with any kind of framework that literally regulates this, how does a larger one make it easier?
I don't think it makes it easier, but I do think it makes it more just. And I think that's an important intersection that the solar geoengineering community really hasn't grappled with yet. And that's not to say that that makes it easier. I think we're going to see a massive diversity of voices that want totally different things, whether that's in terms of outcomes or process, and that have very politicized or polarized views. And I think it's going to be incredibly difficult. I don't have any sense of like what a good system is going to look like, but I do know that it has to be incumbent upon us to start thinking about that now and to try and build a broader community of people who want to participate in that. I know that that's, you know, it's naive to think that we could get there, but also how could we not try, right? Because the idea of this exists, and I don't see a world in which this conversation gets easier to have or where this topic goes away. I think not having the kind of broader participatory conversation that's built on, you know, trying to limit misinformation and bias. I think, you know, without having that, we get to a place where we see all the dangerous outcomes that we've been talking about. And so I really don't know, honestly, what will happen, but I do know that if we don't start now, we will see bad outcomes.
Right, thank you. Michael, can you hold that thought, please? Let's just get in a few audience questions.
Just I remembered the third point, which was, I remember the third point, which was, I mean, there have been some interesting cultural touchstones recently. And if you haven't seen the Apple TV series Extrapolations, the 4th episode features Ed Norton, and it's about a rogue geoengineering experiment. And it has its own point of view, but it's worth checking out.
All right, thanks, Michael. First question from the audience.
Sam.
Oh, Mike. Nice. Hello. So I kind of latched onto something that you said, Dr. Mann, about scientific uncertainty, about how our models are not yet advanced enough to address some of these questions in terms of near-term and more detailed understanding of climate change. And it's actually been a really extraordinary experience working for the last year on the Safe Climate Research Initiative, which is a small research fund that focuses on solar geoengineering, that what we don't know not only about near-term climate outcomes with global climate interventions, but also about near-term climate outcomes without them. It's the same research. And I'm very surprised at the kind of comfort that we have as a society with just not having that heightened investment in evaluating climate outcomes, or just not having, to your point, any serious global efforts to I read a statistic recently, I don't remember where, that not only is only a very small fraction of climate research focused on researching climate risks in Africa, but most of that funding isn't even in Africa. It is funded, it's funding that goes towards North American and European research institutes. So whether or not you're like for or against this stuff, like how do we kind of break down that complacency and lack of interest in really investing in better information about the usable information about what the near-term climate risks could be?
I guess addressed to me, or we can all comment if we like. So yeah, thanks for that question. You know, obviously it is gratuitous of me as a climate scientist to want to see a lot more funding for climate science. And there is quite a bit of work that is being done. Actually, Gavin Schmidt, director of the NASA Goddard Institute for Space Studies, gave a seminar here earlier this semester about sort of the state-of-the-art climate models. And they've come a long way, even the last couple of years. But there are some outstanding uncertainties, particularly with regard to things like how does the El Nino phenomenon, how is that going to change in a climate changed world? And so, yeah, you know, people often ask, you know, do you support research into geoengineering? And people are surprised by the fact that I say, of course, I support it. If for no other reason, the research itself may in fact better inform us as to some of the potential unintended consequences of these sorts of interventions. So let's do the research, and we can talk about what we mean by research, because modeling research is one thing. Actually deploying, geoengineering experiments, field tests, that opens up a whole nother can of worms, which we can probably get into a little bit. One more point, since you talked about sort of the issue of the colonialism in some of the, as did SHUCHI, that this, this does remain a problem. It's mostly, white men in the global north telling people in the global south what we should be doing. And I stand here as a white man in the global north saying that. There's a fascinating New York Times op-ed that just came out yesterday. It just appeared yesterday. And I don't know, we may have an opportunity to get into that a little bit. And it was pretty dogmatic in its viewpoint. It was from an African climate scientist. And the title was something to the effect that, don't use our continent.
My continent is not your climate lab.
My continent is not your climate lab. So the title alone, I think, does a pretty good job in conveying the point of view of that op-ed. And it's actually a complex. SHUCHI and I were talking about this. It works both ways. Colonialism, charges of colonialism have been used by both sides in the geoengineering debate. So it's actually a really interesting issue to talk about.
If I can just a very small amendation on this, not amendation, just additional point, really, like if you're really interested in any particular driving research, not that, a very imperfect way to do it is, this is since the last IPCC cycle is now officially complete, the early stages of preparation for the next one are beginning. And this is the period of time over the next year when countries are going to say to the IPCC what they wish to see in the next cycle, chapters and special reports. Now that doesn't itself create the research, but it's like a demand function. So if we know that the IPCC is going to have a special report on, near-term climate risks or whatever, then that sends a signal down to a lot of researchers. Oh, this is, need for this work, because everyone wants to get their research, summarized by the IPCC. So, obviously the most important thing is funding being available for it, but another, both as a kind of outside advocacy through CSOs, but also through governments. I mean, that is an actual place that those of you who are interested in trying to nudge the huge, lumbering robot that is science into this direction could use.
One more thing I want to add, and I would love to have a larger conversation about that op-ed as well. But I think the really difficult thing about thinking about where research happens and who funds it is that, we talk a lot about how there isn't as much participation in the global south, but there isn't a lot of activity on trying to change those dynamics. And so when we think about how research questions get developed, who's developing them, are we building the capacity to enable them to develop questions, who's funding them, are we enabling local funding partners to build out that work, or is it globally north driven funding towards a specific narrative? I feel like those are all questions that we still really need to grapple with before we start kind of trying to paint a picture of, any particular kind of narrative that exists today. And I think, that's obviously very complex. And I think there are good and bad actors, both in the global north and the global south. And it really takes a lot of effort to think about what are the best structures to develop those conversations in.
All right, thank you so much. Let's look forward to our second question. Did somebody on this side of the room have a question? And Shannon, if we can tee up a question from Zoom in the meantime.
Any of my students in the audience?
So my question is kind of directly in response to your comment is, when you have these funding dynamics, maybe private, public, or concentrations in the global north, how does that then affect the accessibility down the road of who gets to use this technology? How is it regulated later on? Maybe if it's concentrated in the global north, then do they have a say in when it's deployed, if there's a scenario in which these technologies are being used?
Those are all such good questions. And I think we don't really have any answers to that right now. And, the work that I'm trying to build with this new organization is trying to build more knowledge and accessibility to help answer those, to try and build a lot more participation in the places where there might not even be any knowledge that this is even a conversation that's happening, right? So to build those pathways, to build more collaborations across civil society and policymakers across regions of the global north and south, between, between the global north and south, across the global south. And I think, we're not going to see how we get to answers, I think, for some time. But I think we start trying to think about what infrastructure we need to be able to get to the best version of those outcomes.
Any quick comments from either of the Michaels? No? All right, Zoom question, please.
So assuming continued prevention of cooling, SRM or other geoengineering technologies, who on the panel believes that we will be able to control the temperatures within a safe limits, example, below the 2 degrees Celsius? What data or assumptions do you have to base your beliefs on?
Was the question without SRM, or is there evidence that could you just give us the first part of the question again?
Sure. Assuming continued prevention of cooling, whether that's with SRM or other geoengineering techniques.
I'm not sure I understand the question.
What if we assume the question means,
I think I have an idea.
Okay, wait, go ahead, Mike. Yeah.
I think I have an idea what the question is getting at. Is there any way of stabilizing warming below these critical targets without geoengineering?
Yes,
1.5 C or 2 C, and if not, how does that change our perspective on geoengineering? I have my own thoughts, but
yeah. Well, I think the answer is obvious. Like the scientific answer is yes, and then there's the question of the political answer. So, but I think we all agree. Absolutely, yes. All of these things are possible. Mike has a nice long discussion in his book. If you turn off if we get religion tomorrow, I don't think you put it that way, but and we do, go down to if we hit 50% reduction by the end of the decade and net zero by 2050, no problem. 1.5 is possible according to the laws of physics and chemistry, is how the IPCC put it. And then there's the political question. So if you look at the NDCs, so these are the nationally determined contributions, what countries committed to under the Paris Agreement. I believe we're at the point now that the conditional NDCs, meaning the ones that are assuming that lots of money will flow from north to south, gets you into the mid 2 degree range. And that if you add to that all the other pledges that everybody's made, private and public, you can squint and see 2.1, 2.2 degrees. So
under 2, according to some calculations.
Yeah, I mean, the different UNEP says 1 and UNEP around 2, let's say. Yeah. So I think like you could say if everybody in the world does everything that they say they're going to do, including all of the transfer of wealth that's called for in NDCs, then it seems like there's political, and most importantly, there's been a trajectory of a downward good trajectory. So the political process has been good. It's just not been fast. So that's the reason that we all hope that we would never have to actually have this conversation about deployment. The question is like, so it's possible physically. I'm a chemist originally. It's politically, you squint and you can see it, but also there's a lot of counter pressure. As Mike said, there's the big oil producing countries who are part of the global south. There's countries in the global south who are dependent on those in other countries who wish to block mitigation action. There's in this country, there's the most progressive administration ever on climate, and yet continued fossil fuel exploration. So, I mean, I think that it's a very complex question if there's a political reality. Philosophers like to talk about the distance of possible worlds to the current one. It's a possible world. It's not so far away, but we're not there yet.
And one more thing I'll add is I think that the political nature around solar geoengineering will likely shift in that context, right? Like even if we hit net zero by all the targets that we've created, even if we hit it before, we're going to see increasing impacts. And so thinking about how shifting political demand or anger might change the way solar geoengineering is perceived or talked about is also really critically important to consider. Whether or not you want solar geoengineering to happen, which I'm not advocating either which way, but that context is going to shift rapidly the next decade.
1.5 is not a safe world. Maybe that's the way to put it. 1.5 is a failure too.
1.2, which is where we are, is not a safe world.
Exactly. Yeah.
All right, so I believe we might be out of time.
Oh, my goodness.
One last question. Gentleman here.
This seems to me as one of those few subjects where there is basically no room for compromise. You're either going to have to do this on a massive scale, or you might as well not do it at all. And the compromise idea, I just don't see how it works. And now I'm more concerned about the idea of false hope. That there is a lot of society and a lot of pressure and a lot of industries that are looking for an excuse to not cut the greenhouse gases. And this possibility would give them some ammunition. That's,
I mean,
what I'd
this
like
is,
to hear
this
about.
is sometimes called the moral hazard argument. And I would just say, like, this is probably where Mike and I disagree the most. I just think there's so little reason, like, it's not as if everybody's doing a great job, but then this, this technology is developed and people will stop. We're just, like, the reality is, like, we're going in the wrong direction, at least medium, if not, full on the wrong, like, we may not be 180 degrees from where we need to be, but we're not, walking the right path. So I think moral hazard, it's not like we're doing such a great job with mitigation and now all of a sudden someone mentions this possible technology and then they stop doing it. So I just think I get the concern, but I just think it's a bit misplaced here, but we disagree about this.
And one thing I'll add too is I think most advocacy in solar geoengineering is against solar geoengineering.
Absolutely.
There's almost no proponents for advocating for deployment. I would say there's zero proponents advocating for deployment outside of a rogue company. And if there are advocates for solar geoengineering, it's largely for research. But most of the advocates around solar geoengineering are very opposed to even thinking about solar geoengineering or even a conversation. I would say, the idea of the fossil fuel industry getting involved in this space is terrifying to me. I sincerely hope that never happens. But that's also not happening right now. And there's also next to $0 being put into solar geoengineering, both from a public and private perspective. And I hope, we start to see shifts in kind of thinking about how funding can build governance structures to help prevent the exact scenario that you talked about. But I will say, like, I think the moral hazard argument is just something that right now I don't think is at play at all.
I mean, I'll just say it might be more at play in direct air capture, and you do see, say, Saudi Aramco investing heavily in this. And
I would agree.
yeah, so that's a different story.
All right, so let's just have final comments from the three panelists. What's viable, what's not?
Michael, I'm happy to start out. I want to thank Glenn Hurricane Schwartz here in the front row, NBC meteorologist, longtime Philadelphia NBC meteorologist, for that great question to end our Q&A here. I think that this is the beginning of what I hope will be an ongoing conversation here at Penn. And again, one of the things that I love about being here is that we can host these sorts of conversations with great people in the audience, great students, and talk about things that some might want to think of as taboo. We're about open expression, and it's okay to civilly disagree with each other. So I think that's what we have here. I find compelling the arguments against engaging in these sorts of geoengineering interventions. I do worry about the moral hazard. I do see bad actors like fossil fuel companies, like Rex Tillerson, like Saudi Arabia, trying to use geoengineering as a crutch for delaying meaningful mitigation. So I'm less sanguine about that. But again, there's room for an honest difference of opinion on these matters, and I think that's what we've got here in this group.
Yeah, no, I totally agree. I'm so thankful to have this conversation at Penn, and thankful that we can also start building, conversations where we see nuance. I think that's really been missing in the solar geoengineering space. And I hope as more people are willing to engage in this conversation, we can see a lot more nuance in the political, physical science, social, justice spaces around how solar geoengineering could interact, with these ideas. The last thing I'll say is a bit of a plug for my new organization, which is, focus on the intersections of governance, justice, and solar geoengineering, and just trying to build the inclusion necessary as the foundation for, how this discussion moves forward. And so would love to chat with anybody more about that.
Thanks. I'll just say, I think there's almost no disagreement, except maybe about the moral hazard argument between us. But I do think that, I guess I'll just come back to it. I think the answer to this question is nobody knows, and it's sort of embarrassing that nobody knows. And maybe the other part of disagreement is I actually think we should advocate pretty vigorously for research and maybe including something more than just simulations, only because we don't know the answer to this. Some people, if you think that there's the possibility of fossil fuel companies and Rex Tillerson's pushing on this, all the more reason that we want to know be able to answer this question authoritatively. And I would hope that if we come back and have this conversation next year, we know more, because I mean, Mike and I have been talking about this for quite a few years, and Sam, all of his years when he was an undergraduate here. And I just feel like we know incrementally more, but barely. And it would just
We're
be
so
really
proud he's all grown up now.
Yeah, exactly. It would be really, really good to actually be able to base and answer that question on research. And that's what, that's what we're here to do in a university. So
I think
thank you.
one
But I
more
also
really
wanna-
quick thing.
Yeah,
I think the other thing we're missing is that we really don't know what anybody else thinks about this topic. We
I
don't.
was going to say that's part of the that's part of the viable is
Right, yeah.
not just the physical science of it, but it's exactly what you're talking about. It would be really good to understand what the SIDS, who are the most vulnerable to climate change, well, shouldn't say that, but the most vulnerable countries, what they think about this is really important. And there's not been one survey ever on that subject. So.
All right, so final thought here is something that I heard from SHUCHI, and this could be a huge opportunity to build infrastructure that has not yet been built. So on that note, I'd like to thank all of you here with us today.
Great.
Thank you to those on Zoom, and let the conversations continue. Have a good day.